Welcome to our final session in our second week together in data analytics. I'll be walking us through examples in SPSS to demonstrate how to use SPSS to better understand samples and populations, as well as data distributions, summary statistics. And with this demonstration, we're going to be moving much closer to creating an analytic plan. So as we said earlier, our time together this week is really looking at how we're drafting questions to understand the wicked problem of readmission, and how sample and population is the key concept that's going to help us draft our question, understanding what data we have access to in this data set. And then we're going to be continuing to apply our skills in exploring data, looking at the distributions, central tendency, and variance within those variables, as well as the relationships between the two. So let's turn to SPSS. As we begin this part of our time together, go ahead and open SPSS and load the data set that we're working from and come back and join us. All right, now that we have SPSS open with our data set, let's take a look at how some of these dynamics of sample, population, descriptive statistics, correlations, and graphs all relate together. So let's take for our case example pneumonia for week 2. And let's get a better understanding of a couple of the variables within the pneumonia readmission process. So let's go to Analyze Descriptive Statistics and Frequencies, and we're going to pick some key variables. So let's look at pneumonia discharges from it should be in this list. I'll vacate my variable list so we find them all together. Let's look at how giving discharge instructions is the number of pneumonia discharges and the number of pneumonia readmissions can be described. So if we go to our statistics menu, we're going to select quartiles to do the interquartile range in case our data are not normally distributed. That's paired with the median. It's a measure of central tendency. And also, let's look at the mean in case the numbers are normally distributed, and that's paired with the standard deviation. So we'll say, okay, those are good measures of central tendency and variance. Let's continue. And this week, let's see how we can integrate the charts, some key charts and graphs, with our descriptive statistics. So we'll select the histograms and showing the normal curve on the histogram. So the histogram is a tool for looking at data distribution. That's really what it's best known for. So let's see what we get when we run that analysis. So the way that we interpret the SPSS output is we're looking here at frequency, and in the statistics box, we're looking at N, which is the convention used to designate the number of observations we're looking at, mean, median, standard deviation, and percentiles. So those key summaries of central tendency and variance are here on the left-hand side. The number that are valid and missing, absent in our data set, are shown here. And then the statistic for the variable is across the top. Discharge instructions given, the total number of pneumonia discharges, and the total number of pneumonia readmissions. So the first thing I'd like to think about is what we know about sample and population based on this summary table. You know that sample and population are related to each other because observations, people, or hospitals that are in our sample have been drawn from a larger target population. And we know that the data set we're working with has observations on about 4,000 hospitals in the United States that takes Medicare. So when we look at this summary statistic, let's see how many observations we have data on. You can see here that we have 2,835 observations on discharge instructions, but we have no data on 1,849. So if you calculate the percentage, this is going to be somewhere on the order of 2/3 of the facilities that we have data about. So when we think about, is our sample that we're running this analysis on, is it generalizable to the entire population? And when we have a third of all of our data points missing for this variable, it certainly does raise questions about how robust are these data to speak to the experience of all U.S. hospitals. So that's one thing to think about, but that's only within this data set. So sample and population is usually much broader. And in our example, we said that all hospitals in the United States that take Medicare would form the population. Our data set is on 4,000 of those, approximately. And for this particular variable, we have 2,800 observations. So you can see we're working with a much smaller number than all hospitals in the United States that take Medicare. And we have to think about that as we're interpreting our data, because the number of observations we have to speak to the whole and how many missing observations we have certainly influence our interpretation. And talk more about that as we go on. But take a moment, I'd like you to examine the mean and the median for these data, for the discharge instructions given, the number of pneumonia discharges, and the number of readmissions, and tell me how you would summarize the distribution of those data points as normally distributed, left skewed, or right skewed. So let's take a look at how your summary compares to the histograms that we've generated in SPSS. Now, you'll see here we have a frequency table. It's just quite long. It lists all the observations for each of our variables that we're looking at, and it's a lot of information. I'll show you later how we can select for that chart not to appear in our output. But in this output that we have, let's begin to look at our histograms. So let's see, and for discharge instructions given, on the bottom x-axis we have the proportion of hospitals who are giving discharge instructions, and on the y-axis we have the frequency, how many hospitals are doing that. So you can see the vast majority, about 1,200 hospitals within our sample here of 2,800 hospitals are giving discharge instructions. And if you looked at the mean and median, you would see that there's likely to be a left tail here that you see in the histogram, and so these data are left skewed. Let's look at the number of pneumonia discharges in the histogram. So again, you could make some assumptions about how these data are distributed based on the mean and median, but the histogram is a very powerful tool for getting a picture. So you can quickly look here and see how the data are distributed. See, the majority of observations on the number of pneumonia discharges is happening here on the left. And then we have a right tail of observations that continue out to approximately 1,500, and there are a few observations out here all the way to just before 2,500. So these data are right skewed for the number of pneumonia discharges. And the number of pneumonia readmissions is also right skewed. You have a large number of observations on the left, a tail of observations going out to the right, and so you have right skew. Consequently, in our data set, we've looked at the distribution of the variables for pneumonia discharges, pneumonia readmissions, and discharge instructions. So let's now take that understanding of distributions and take a step forward, thinking about right skewed data, left skewed data, and how that distribution can affect our analysis. So let's begin to think toward our inferential analysis, how we can take the understanding of this variable and understand the population more effectively. So as we've said throughout the course, the key idea in analysis is we want to relate a predictor outcome, a predictor variable or multiple predictors to an outcome. And the relationship between the predictor and the outcome, and the way we understand it, is going to be guided by the distribution of the data that we're analyzing. So in our example, we had data that were primarily left skewed or right skewed. But what we have not yet seen is how the predictor variables are related to the outcome variables. So the histogram showed us how each data point is distributed, left skewed, right skewed, or normally distributed. But when we look at a scatter plot, it's going to compare the predictor to the outcome simultaneously. So let's generate a few scatter plots that relate predictor and outcome variables. So we're back in SPSS again. I'd like you to go to your navigation bar at the top, and let's go to Graphs, Chart Builder. And this time, let's take the relationship between discharge instructions being given and put that on the x-axis, and the number of pneumonia readmissions. So we'll scroll through our variables. Here's pneumonia readmissions. We'll drag that over to the y-axis. Now that that is on the y-axis, we're going to be sure that we select the scatter plot from the gallery. We'll drag that up and tell it to OK. Let us generate that graph. So let's see how those two variables are related to each other. So here you can see that the proportion of hospitals giving discharge instructions is very heavily clustered here on the right-hand side of this graph. And the number of readmissions is increasing here on the left. So if you were to describe the relationship visually between these variables, you'd say, well, based on this scatter plot alone, it seems that the more hospitals give discharge instructions, the more readmissions they have. That's kind of an interesting concept, and we'd have to think a little bit more about that and why that is and what does that mean. We have to interpret this graph more. But this scatter plot shows us the relationship. So let's do the same for another variable set. So let's come back to SPSS. We'll select Graphs, Chart Builder, and we're going to go to the gallery, select the scatter plot, and this time let's examine the relationship between hospital readmissions and hospital discharges for pneumonia. So we'll expand our variable view here, scroll down to pneumonia, and let's say that we want to see how the number of pneumonia discharges on the x-axis could be used to predict or understand the number of pneumonia readmissions on the y-axis. Let's see what we find. Oh, technical difficulty. Let me repopulate the variables. Okay, here we have the correct scatter plot. So on the bottom we have the number of pneumonia discharges and the number of pneumonia readmissions here on the y-axis. So in some ways we're not profoundly surprised that the more pneumonia discharges you have, the more pneumonia readmissions you have. That's a relatively intuitive relationship. What's interesting is to see how profoundly strong this relationship is. You can see it if you draw a line through the center of your observations. It's almost a one-to-one correlation. So as the number of discharges goes up, the number of readmission goes up. And we said before that the proportion of readmissions is approximately 20%. So very rapidly, now we've seen the visual relationship between these variables, let's measure that relationship using correlation. And non-parametric methods would be the best, since we saw that these data are skewed to the left and right typically. But if we look here at the number of pneumonia discharges to readmissions, it's a 0.95 correlation coefficient, the Spearman's rank correlation. So about 0.95% cohesion between these two variables. Very strong relationship that was also demonstrated in the graph. Have a great week analyzing data.